Hey, it is 10 o'clock, and I thought standing up I'd get some better light, but I'm in the shadows. Good morning, everyone. You have made it to our April 18th presentation, HVAC's role in electrification roadmaps, which we've been hyping up a little bit the past couple of weeks. Excited to hear from Kimberly and Karen. Um, and let's get started here. Go slides. All right, if you haven't taken a presentation with the Lighting Design Lab before, we mute everybody, all the attendees, not everybody, the whole presentation, but you may ask questions at any point by going to this questions icon up at well, it's probably in the top of your menu. And that'll come to us and we'll ask them at the end of the presentation. We're recording the webinar, so uh, about a week from today, I usually try to get it up a week from today on our website. You'll have the recording. I think I missed last one, so if you're waiting for it, sorry, I was at a conference last week. And there's a survey at the end of the presentation that'll pop up in your browser window, and we would really appreciate if you take that and give us some feedback. Aside from that questions icon, there's a chat icon, and I'll be pasting some relevant links as they come up, and that's where you will find those. All right, there we go. Upcoming events. After today's, we've got one more for this month. Evan Green is coming back. If you caught his presentation in March, there were lots of questions that didn't get answered. So he has kindly agreed to come back and answer those questions. And if you go register for that, there's a chance to ask some more questions for him to come prepared with on the 30th. And we have several webinars lined up for the next couple of months. One on the green building tax incentives for all you commercial property people, especially architects. And then the our colleagues over in the conservation group. It's not called the conservation group anymore. I've been here long enough that I keep calling it that. Are going to come talk about incentives for our resi markets for contractors and then for commercial markets, kind of a lunch and learn situation there. And then we have Melissa from, oh gosh, what's it called now? Building Potential, who's going to come give a presentation on the role of electrification. And we are going to start today with a Slido poll like we have been doing. So get out your smart device and scan that QR code, or you can go into another browser window and type in slido.com. That 4130131 number is the, I think they call it a presenter. What do they call it? Some kind of way to enter the poll. Oh my gosh, I've lost all brain function. And there's the passcode too to get into it. I was totally prepared, and then now I'm not. It's kind of a weird thing going on. Okay. So if everybody has joined, here's the first question. Where do you do most of your work? Not where do you work, but where's most of your work go on? So I know we've got lots of people around the region who do work in Seattle, so put Seattle. Excellent. Thank you, thank you. So Seattle, Puget Sound, some outside of Washington. Excellent. And then a little bit more thinky one, which I'm not going to even try to answer because my brain's misfiring. But what are you hoping to learn today? What are your expectations for this presentation? I, for one, am really interested to hear from a manufacturer's perspective what role HVAC is going to play or can play. Um, in all of our roadmaps for electrification. I'm going to put myself on mute for just a second. There's some background noise. I'm going to give it a minute because it says there are people responding, but we've got people that are just here to generally hear what's going on. Oh, how to discuss the topic with clients is really good. Availability of high efficiency. Yes, specifically with clean buildings and Seattle BEPS. We were just talking to Kimberly and Karen about that. Now they're not from the area, but I'll put some links in that might help answer, well, start to answer those things. And you can always write to us if you have specific questions. We're part of the building electrification group. The Lighting Design Lab is here at Seattle City Light, so we can chat with you about that. Tips to help clients who are looking to decarbonize and reduce greenhouse gas. How to offset capital costs, that's a big one. Natural gas to plan for electrification, that's a big one too. Okay, next question. Oh, it went past my slide. Now, it's not going to show the slide. The conference I went to last week was the National Home Performance Conference, and they were handing out shirts that said Minneapolis is the blower door capital of the world. So I wanted your guys' opinion. Is Minneapolis the blower door capital of the world? You betcha. Oofta, that's a stretch, don't you know? Or hot dish. Now, here's a real test.
Definitely, you betcha. I got to weigh
You
in. I was there
betcha.
too.
You
I don't
were?
know how.
Did you present? Okay. Yeah, I didn't see
Mercifully
your
not.
name. It was really a good conference. I'd not been before, and the lab is sort of getting our toes wet in residential instead of just focusing on commercial. So that was a really, really great conference for everybody out there who's listening. I'm glad people chose hot dish. That's really the right answer. Okay, so now I am going to turn it over to, oops, where's my people thing? Turn it over to Kimberly to run the slides that she and Karen are going to show you today. Thank you, everybody. I'm going to go off camera, but I will be in the background.
Great, thank you. I'm gonna take over the screen now. And since this is the only way this seems to work, just forgive the moment that it takes to get here fully. I would like to confirm with you all that you are seeing my presentation in presentation mode.
Yep.
Great. Katie, thank you to you and Robert for this opportunity to speak to your group. We're excited to be here. I'm going to hand the mic over to my colleague and friend Karen McGunagle to introduce herself. What we're going to be in just a second here, what we're going to be talking about, as Katie said, is HVAC's role in electrification. And we're going to do that within the construct of talking about 4 different case studies. If we move through it quickly, it's really an interest of time so that we have time at the end in order to answer any questions, because I saw some great questions come in, and we want to make sure we allow for that. So Karen, I'm just going to ask you to introduce yourself if you don't mind.
Sure. Good morning, everyone. I'm Karen McGunagle. I work for Mitsubishi Electric. I'm a commercial sales manager out of Washington, D.C. And as Kimberly said, I think one of the greatest ways to learn is to follow people's example. And so what we're going to do is talk about decarbonization, but show it in real life. So we're going to show you how we've applied HVAC to decarb projects. And hopefully you can learn from some of the examples that we share today. So I'll let Kimberly start it off.
Thanks, Karen. So my name is Kimberly Llewellyn. I'm the emerging market senior product manager for Mitsubishi. I have been focusing on high performance buildings for the last 15 years or so, and have a particular love for passive building programs and designs. So that's those are those funny letters after my name. I do wear that banner. I'm a certified passive house consultant. You'll see that two of the projects that we highlight in this presentation are passive house projects. So one is a FIAS new construction, and the other is a PHI retrofit. It might surprise you. Part of our messaging here is a little different than what you might expect from a manufacturer of heat pumps. We're actually very strong supporters of dealing with building envelope loads first, whenever possible, in this transition that we are embarking upon from different fuels, most notably propane and gas, natural gas, to all electric. This is our agenda. We don't promise to keep this order, but one of the questions that came in just now was looking for some suggestions on how to talk to clients about this. And I think this is a really important part of this puzzle. So we will take a minute to address that, and I'm calling that choose your lens. We'll talk about how these buildings are creating resiliency, not just for their owners and occupants, but also for their broader communities. How they're expanding the electric infrastructure as part of that. We're lowering refrigerant impacts, engaging key stakeholders as an absolutely critical part of delivering projects successfully. And Karen especially is going to hit on some of those financial incentives, which should get at one of the other questions that came in. So the choose your lens, this is important to acknowledge and be honest and authentic about as we transition from, what in many markets is largely a natural gas heating and hot water markets to electric markets. Not everybody believes in climate change, and that is just a fact. And a lot of contractors who are expected to do the work of these transitions don't believe in climate change. And so it's important to respect that, first of all. And second of all, to have other language that is also honest and authentic, that describes the advantages of dealing with our projects differently. So one of them is risk management. And we have an example of a project in San Antonio that has gone through both climate extremes, extremely cold temperatures, extremely hot, prolonged, drought and extreme heat wave temperatures. And the way that they went about building their building was really a risk management strategy. It's also a financial opportunity. So when you have a building that has lower risk overall, that has lower cost of operation and maintenance, this is a financial opportunity. You're actually securing the value of what's often the most valuable asset of of an owner of a company. And then for those who do believe in climate change and who are completely committed to being mission-based around this cause, then it's sort of easy. There are a lot of companies also developing environmental sustainability plans or have environmental sustainability goals. And so as we move towards an electrified and lower carbon built environment, it helps us bring both industry and our buildings and built environment into alignment. it's helping us also give larger companies an actual way to put meat behind their ESPs. Sometimes look great on paper, but don't have any teeth. This is something I'm not going to spend much time on because it's a common statistic that I think we're used to hearing. I'm looking for this to, maybe shift over the next 10 years. We'll see if these percentages change, but something like 27, upwards of 27% of our carbon emissions are associated with building operations. And so that's why I think most of us are here. We're focusing on that piece, large piece of the contributing factor. I love waxing poetic about the constructal law, and I'm not going to do that. What I will say, because I didn't cut this slide out, is that I see where we're at as an industry as momentous. We've been in a state of sort of a chaotic regime, for those of you who think in terms of energy flows or fluid flows, which is necessary for disruption and for change. We're now at a point where it's really important to find the laminar flow, or to create it. So connecting the dots between different communities that are aligned, mission-driven, and aligned in those missions, manufacturers and utilities, project owners and contractors. It's critically important to sort of picking up the pace of the transition so that we can scale this effectively in a time frame that's going to meet sort of the critical time frame that we're in. So what are the general strategies for decarbonizing our built environment? The way that we are orienting ourselves is actually starting with reducing building loads wherever possible, as I mentioned in the beginning. So we do that, by means which you all are looking at the attendee list. I'm sure you're all aware of, but where it's possible to add insulation, especially continuous insulation, might mean a panelized retrofit of a existing building, swapping out windows, air sealing, reducing internal loads that might be creating, excess cooling loads. And you could probably should add, energy recovery ventilation as part of this reducing of base building loads. So once you've done that, or at least evaluated the possibility of that, that's when we want you sizing your heating and cooling equipment in order to really maximize the lessening burden of the electrical load on the grid and on the community. And the next strategy that Karen's going to talk a little bit more about is maximizing the financial benefits. We're all aware of the IRA coming out, the tax incentives, 25C, 45L, and then some other lesser known tax benefits that can be taken advantage of. One that is really the next strategy that's very near and dear to my heart is about engaging all of our key stakeholders. And for me, my largest focus is probably in engaging our contractors and our skilled trades. I'm very sensitive to the fact that a lot of our policy changes have come from above, have come from a theoretical standpoint, which is okay. It's not necessarily wrong, but these our policies and this push should not advance without the engagement and without the active input in the earliest possible stage of the people who are expected to do the work. I think it's right for one thing, but I also think it's critical to the success of the execution of these of this push to electrify. We'll talk a little bit about the reduction of refrigerant impact. I don't know if any of you read Drawdown, this book that sort of prioritized, ranked the impacts of different factors on climate change, and mismanagement of refrigerants was, and refrigerant leakage and impact of high global warming potential refrigerants was one of the top factors. So we are in the process of transitioning industry-wide to, and that's throughout the US, and this is a federal requirement in law, to transition to lower GWP refrigerants. And I'll give you some of the highlights of that at the end of this presentation. And then obviously we need to build out our electric infrastructure, and switching to electrically powered, especially heating and domestic hot water systems, is an essential part of that. So I'm going to skip this one in interest of time, but the header on this is really the point. Every building that we bring online and every retrofit that we engage in should result in an asset to our grid and to our communities, not a liability. And so often, you know, we bring a new building online, an all glass and steel structure, for example, in a hot, humid climate like Austin, Texas, seemingly without the acknowledgement that that building has immediately entered the built environment as a liability. And it will likely have a 50-year lifespan, and it will be a liability and a draw on the grid for that long, at least. And so I look at it through this lens. It's not just like, let's get through the finish line of delivering certificate of occupancy to a client. We've got an obligation to our children and all future generations to be delivering assets to them. And by assets, we mean resilient buildings that can maintain their value over time, that will continue to be healthy and manageable and have low costs of operation. And then, when you can add the beauty and the aspects of buildings that make people want to live and work in them, well, that's the gravy on it. So this is an example of that kind of project. This is the Credit Human headquarters building located in San Antonio, Texas. If a group of people are interested in coming down to take a look at this firsthand, I would be happy to give a tour. This is a 12-story Class A office building. What you see is a beautiful masonry building, which is hard to find in Texas. They're still so often glass and steel. What you don't see are some of my favorite features of this building, and I'm going to hold off a little bit on that just because I've got a slide with pictures. The ground source heat pumps are an absolute cornerstone of what has made this a resilient building. It was also one of the trickier design features to get approved because as you probably know, upfront costs for drilling wells, especially in an urban environment, is pretty steep. But we had an owner who had set the goal of delivering a 100-year building. They retain ownership of their buildings for this is a 115-year-old about a 100-year-old credit union, and their last headquarters they held for 50 years. So they have a track record of understanding the value of having a building that retains its operability and low cost of maintenance over time. They were also determined to, this was in design clearly pre-COVID, but it was actually delivered during COVID, and having a place that was absolutely beautiful and comfortable to work in helped them get people, out of their homes and back into the workplace and want to come to work, in person with their teams. There were also some other tailwinds. San Antonio was one of the cities that signed on to support the Paris Climate Accord after we pulled out nationally 5-6 years ago, and so what a lot of cities are finding, and this is a subject of conversation more and more, cities committed to their 2030 and 2050 carbon reduction goals and then didn't know how to do it. So we're seeing more and more incentives like this one, like a decade-long 100% tax abatement and 5-year tax rebate, coming from cities who made those commitments and now are recognizing the value of this type of project in supporting them meeting those goals. So this is one of that's probably my favorite part of this building, not just because, I think fluid applied air barriers are great and provide performance that is hard to meet in other ways with this kind of commercial building, but it's really more about the people. So this is a Texas general contracting firm, excellent skill sets and management on this company, but they had never done anything like this. And the owner had incentivized an air tightness goal of less than 0.1 CFM per square foot at 75 pascals. So code is 0.4 for point of reference, at least in Texas, and then Army Corps of Engineers is 0.25. I think I have that right. It's 0.2 or 0.25. And the owner wanted it tighter than that. And so he, when I say the owner, I mean the ownership, the credit union. And so they incentivized it with a large bonus, basically, if this crew was able to hit the goal. And what you see in the middle picture is a vacuum, a vacuum system that is testing a brick tie. You saw that this was an all masonry building. There were approximately 10,000 brick ties on this building, and they did not batch test the brick ties. This young crew with no experience of this sort, they tested every single brick tie. And the results you see on the right-hand side of the screen, they hit that. They blew past the goal. And what's so exciting about that is you can't unlearn that experience. That team, they were proud of the work they had done, rightly so, and now they have taken that forward with them in their career and have that awareness for their next project. It also has continuous insulation, which I'm sure you all know is important, especially in climates that are more extreme, granted, than Seattle. But creating those thermal breaks has a huge impact, not just on loads, but also on condensation within building assemblies, which can impact the durability and sometimes structural integrity, as well as the health if you end up growing things within interstitial spaces that can result in things like biological growth. The ground coupled VRF, heat recovery VRF systems was another really key part of this all electric, I should have said that, project. So there are 150 wells, quite deep, and they were designed to meet 100% of the heating load There's no auxiliary heat on the building, no electric resistance. And I've got an example that shows that the capacity of those wells is enough, even in very extreme conditions. It needs about 70% of the cooling load, and there are 2 cooling towers that were reduced from 6 cooling towers. So we've got 400 tons of peak load cooling capacity. That's an 800-ton reduction from what the design was originally. Talking about resiliency in action. So I think it was made national news that what we call snowvid or snowpocalypse of 2021. I was here with my 2 sons. We kept power but lost water. Much of the state lost power and water for, in some cases, a couple of weeks. The outside temperatures were actually in the single digits, which for us is, we build our buildings, our new buildings, according to code, which assumes maximum temperature differences of about 40 degrees. So compared to what our design temperature, what our interior cooling heating temperature is, what we were actually experiencing was like 60 to, upwards of 60 degree temperature difference. There was tremendous loss across the state, pipes freezing, people freezing, lots of damage. So there was something like $11 billion of insured losses. Those were just the insured losses. So the uninsured losses and the actual losses were easily a magnitude or greater than what's represented here. Commercial properties, and I'm taking a minute to put a spotlight on this point in particular because this is the kind of consideration that never gets factored into ROIs. So when we look at a measure like high upfront costs of digging 150 wells for a ground source system, or adding exterior insulation to a building envelope compared to the potential loss of an event like this, which is completely unpredictable, we're really missing. We're putting blinders on, and so when we look at ROIs, or at least have those discussions, we need to highlight this factor. And again, this factor is by creating a resilient building envelope and having systems that are less susceptible to impact of extreme climate events, you are ensuring the safety, the durability, and the resiliency of that building and of the people inside of it, and of the investment itself. Oh, so it's on the screen here, but that building, when it was 12 degrees Fahrenheit outside, we've got a screenshot that was too poor quality. My marketing department would not let me use it, but it's a building automation system screenshot that shows 12 degrees outside. The building was maintained with no auxiliary heat at 68 degrees just from the well field and our ground source heat pump systems. Karen's going to touch on this as well, so I'll be quicker about this, but that reduction, I mentioned that originally there were 6 cooling towers in the design, and we reduced that to 2 cooling towers. This is another thing that doesn't often get factored into a return on investment or a comparative upfront cost analysis is, if you look at the increased cost of water, and not just the water consumption, right, but also the sewage fees, and then you look at that savings associated with not having cooling towers and also having things like water catchment. It can be over time, it can be a really significant savings. So I've got this analysis showing that just the cooling towers alone over 10 years saved over $500,000. And this is my my hats off to all of the people that made this possible. Again, especially the skilled trades and the ownership of Credit Human, who's in the lower left-hand corner. That's Steve Hennigan, the president CEO, and Bill Schoen up in the upper right-hand corner with Silver Ventures. They had the vision and were willing to take the risk to develop and deliver this amazing project. And it only was possible because they incentivized and supported the people doing the work all along the way. Also, a few of my teammates, Jamie Armstrong, Chris Vandegrift, Chad Hall, were instrumental in our team for making this happen. With this, I'm going to hand it over to Karen to talk to you about another new construction FIAS project. It's located in Bronx, New York.
Thanks, Kimberly. So our next project is Trinity Financial's 425 Grand Concourse. And this is a 277 unit mixed use, mixed income affordable housing project in the Bronx, as Kimberly said. This affordable housing project is appointed with top-notch amenities. So they have package rooms, fitness centers, meeting rooms, lounges, and rooftop views of the Manhattan skyline. So it's a beautiful, absolutely beautiful building. The project provides rent-stabilized housing for housing challenged and low to moderate income families. And they do that via a lottery system. And every year you have to reapply for your housing within this building. Through massing and site design, the project mixed well with the community. They offered community-based services within the building, including education, healthcare, and retail. And this is, as you can see, a very large-scale building in this neighborhood. And they took care in selection of the metal panel construction, which is a little hard to see in this picture. But they selected the metal panel construction to break down the large scale of the building. And then they also selected the narrow shape of this building to minimize shading on Garrison Park, which is a nearby playground in the area. Slide. So this building used a gas-fired condensing boiler for domestic water heat. Now, at the time, hot water heat pumps were not widely available, but would be a consideration if this building were to be designed today. The building was extremely airtight and energy efficient, limiting noise and heat transfer. They have triple pane windows with 28% window to wall ratio, continuous thermal barriers and air barriers, all contributing to a detailed envelope system. They have expansive windows that provide abundant daylight while balancing the window to wall ratio required for FIAS projects. The apartments are all electric design as well. So the apartments have LED lights, electric heat pump dryers, and induction cooktops within the space. And the building is designed to operate in extreme weather conditions and for extended power outages. So for example, if during the winter they lost power, the building is designed to retain heat inside the building, keeping the interior above 50 degrees for several days. That heat retention also limits potential freeze damage to the pipes and other components of the building. Slide. At the beginning of the design process, the team conducted a passive house feasibility study to assess whether the building could achieve passive house certification. And the GC was brought in early to determine if the building could be built on time and on budget with a variety of trades. So the GC was committed from the very beginning of this project. And by adhering to passive house standards, obviously the building will dramatically reduce energy use and carbon emissions because passive house performance buildings just drastically reduce loads, ensure quality design and execution of the building envelope. They address thermal bridging and condensation potential and requires high efficiency from all the systems, especially HVAC. This building has a predicted site energy use intensity of 22.1. And a typical multifamily residential project has a EUI of 59.6. So this was a substantial reduction in energy use. In addition, this project meets the Enterprise Green Community standards, and the design incorporates the New York City Active Design Guidelines, which encourage physical fitness by including fitness rooms and trails near the building. Slide. The building was designed such that the internal gains are sufficient to offset small amounts of heat loss during the winter, so that this building is primarily cooling dominant most of the year. And that's really unusual if you think about New York City and the climate of New York City. They have large-scale sunshades on the south side to reduce solar load on the south side of the building. They use a VRF system, which provides high efficiency at very low loads. They have energy recovery ventilation in the building, which brings in fresh air and removes stale air. And then they have a control strategy of energy apportionment, which actually can distribute the energy use of the apartment, so by tenant or by apartment space, and show the electrical and cooling consumption of the energy utilized within each apartment building. New residents in the apartment are given an orientation explaining the energy saving components in their apartment so that they buy into the energy efficiency features of the apartment. Slide. Slide. Thanks. Stephen Winters Associates was the commissioning agent on this project, and they were given a DOE grant to monitor the building. So as we said, we want to make sure the buildings are built and operate the way that they're intended. And so there is a DOE grant applied to this building, and they're making sure that this building is operating the way it was intended. As far as energy apportionment, the way that it works is we have a revenue grade power meter at the outdoor unit, and it measures the kilowatts utilized at the outdoor unit. Then that data is collected by a pulse input controller, and then a central controller collects all of that data for each indoor unit, and an LEV valve in the indoor units measures the position of the valve and the amount of refrigerant delivered to each indoor unit. So in this situation, 1 meter at the outdoor unit can serve up to 200 indoor units. So this is a fantastic practice if you want to take a look at what your clients or customers may be utilizing, or this can be utilized to bill your customers for energy utilized within their apartments. Slide. Another benefit of energy apportionment is that it gives us actionable data, right? We can take a look at what's going on in that building to make sure the building is operating the way that it should be. 425 Grand Concourse is the first time that we have ever differentiated between the energy utilized for heating and cooling. And so although we don't use that data for any billing function, it does open up some future opportunities that we could bill for providing cooling in a building as opposed to providing heating and cooling. We could just bill for one function or the other. Slide. So let's go from affordable housing to luxury apartments. The Regency is a building in South Florida that is in construction at this point. The building offers apartments from 2,000 square feet to 14,000 square feet on the top penthouse buildings. They provide long-term leases for these family homes in the sky, and the reason is that people prefer apartments over the hassles of condos and the condo association fees. The HVAC system includes a VRF system, hot heat recovery, hot gas bypass DOAS system, units, rooftop units, and controls. And the building has a north-south split to take advantage of building diversity. Slide. So as Kimberly talked about the cooling towers on her project, if we had looked at this project and utilized cooling towers, the project was about 800 tons. This building would have used approximately 7.5 million gallons of water per year. And as we talk about decarbonization and the efforts to decrease the consumption of fossil fuels, I think we also have to consider water as a valuable resource and how can we protect this resource as well. And cooling towers isn't the only way to mitigate that, but also water conservation can be mitigated through low flow water fixtures, water leak detection, and irrigation practices that you saw on Credit Human headquarters. Slide. So this project was owner driven, and so the developer used cost segregation as a strategy to quickly deduct the depreciation of the property against the taxable income. And so instead of looking at the building as a whole, cost segregation allows you to look at the individual non-permanent components of the building instead of the entire building. And so the components include capital assets like your furniture and your office equipment, window treatments, but it also includes your systems, so your electrical, plumbing, and mechanical systems, including HVAC. So although this cost segregation is just not just a conversation about HVAC, it is something that you should talk about with your building owners. When you look at the building components, you can just quickly speed up the depreciation schedule, and you can get a reduction in taxes. And on the Regency, the potential is a $9 million tax deduction at their first filing. Cost segregation does require a study, and in this case, they used a company called Engineered Tax Services, and that's best done when the building is purchased or as the building is being built. Slide. So everyone is talking about the Inflation Reduction Act, so we need to address that as well. This building did receive or will receive significant benefits from 179D and 45L. The same company that looked at cost segregation, Engineered Tax Services, looked at the potential benefits for 179D and 45L, which we'll go over in the next slide. So 179D was developed as a deduction to make commercial and 4-story or taller multifamily residential buildings more energy efficient. The deduction is based on ASHRAE 90.1 2007, and you have to beat the energy model by 25%. The deduction amount is really built on achieving energy gains through lighting, HVAC, hot water systems, and building envelope design. The deduction can increase up to 5 times more when the contractor uses prevailing wage requirements or has apprentices on the job. And there is a 179D opportunity for retrofits. And so what it does is takes the EUI of the existing building, and that EUI model has to be beat as well to receive the deduction on retrofits. On this project, there's an estimated benefit of $360,000 for this building based on how it was designed. Slide. Uh, 45L is another tax credit, and it's designed for new energy homes. So it's new residential construction, including multifamily construction. The multifamily buildings have to be eligible for Energy Star's multifamily new construction program. And there's additional credits available if it meets the DOE's Zero Energy Ready program as well. And on this project, it's still under construction, but the estimated net benefit will be between $25,000 and $590,000. So another substantial tax benefit for this building. Slide. There is another tax credit for it's Section 48, and it's considered for new energy properties, as shown on the screen. And Section 48 is a credit to encourage investments in renewable energy generation and other clean technologies. And the credit amount ranges from 6% of the base rate up to 30% of the cost of the project if they use prevailing wages and apprenticeship hiring requirements. You can also gain additional credits if domestic content requirements are met, or if the project is built in an energy community, such as a space where a coal mine has been closed. Slide.
Were there any closing comments, Karen, on that section?
No closing comments on that last section. Back to you, Kimberly.
Okay, thanks. So our final project that we're going to talk about is the Hotel Marcel, located in New Haven, Connecticut. This is a Marcel Brewer original design. To my eye, it's gorgeous. If you've ever driven by down, I think it's 95 as you're driving through New Haven, the building jumps out at you. It had been primarily office buildings for most of its 70-year life, and has been reinvented as a boutique hotel. It's gorgeous inside and out, and it has its new lease on life as an all-electric building. So some of the key features of this building, and since we've already talked about, in the first two buildings, we had high efficiency heat recovery ventilators or enthalpy recovery ventilators, heat recovery VRF systems. I won't talk about those as much as the two elements that set this project apart, which are the CO2, so the carbon dioxide refrigerant based domestic hot water system that is being used for all of the laundry, hot water, and cooking for the hotel, as well as the demand response system that's been integrated into the BMS. Some of the typical passive house elements that were incorporated into this project are continuous insulation. In this case, since obviously you're not going to mess with the exterior of a building like this, inside, windows were replaced with triple pane thermally broken windows. There's also, I didn't talk about this on the Credit Human building, which had a megawatt PV array on the roof. This building also has over a megawatt of PV on the roof and a 1.5 megawatt battery array for backup. And that's tied to the demand response system and program, which they have opted into for their local utility. So we'll take a closer look at that. So you'll see the solar array span, it takes up some different spaces within the property, creating shade and shelter for some of the parking, in addition to being located on the rooftop. There are also EV charging stations, which goes that much further to supporting the fleshing out and the building out of the electrical infrastructure, not just for this property, but for the community. So to break that down a little bit more, the CO2 domestic hot water systems, being in your neck of the woods up in the Pacific Northwest, I'm going to guess that you're familiar with some of the Sandin, now Sanco, CO2 refrigerant-based domestic hot water systems. This system is similar. It's larger, so it is at this point we have a system that's large enough for commercial buildings, not well suited for domestic at this point. The advantages of this system is that it's really good at very efficient large lifts, so taking in cold water and delivering a very hot water, and so it's perfect for domestic hot water applications. The COPs annually are something like 2.5. I mean, we get better performance in a lot of instances, but that's sort of the average performance across climate zones. Um, what I will say is that there there was more domestic hot water use than what was designed into the project and what was anticipated. So not an issue with the systems themselves, but actually a caution on the design. Moving down to the PV or solar array plus the battery system, we're looking at the roof here, and you can see some of the parking array as well. I'll talk about this in conjunction with the demand response system because the owners have opted into an agreement with New Haven's utility to partake in demand response events. And they said on average that it's actually the events are occurring about once a month. So the grid in that area is particularly vulnerable and could use some infrastructure shoring up. And this building is being used as sort of flagship example of how new and retrofit developments can support that transition and evolution of a local utility. So what happens is whenever there's a instability in the grid and an anticipated peak load, Hotel Marcel gets a signal through the demand response system and goes off grid. And the battery array and storage of the 1.5 megawatts is what they run off of then for the duration of the event. Obviously, with a hotel, it's critical that they maintain not just their critical operations, but all of their operations. And so far, this has worked well. I think they're about a year and a half in operation. So I think this is probably one of the most outstanding features of this building when we talk about this within the context of electrification. Another piece of that obviously is having these super reduced loads like Karen was describing with the 425 Grand Concourse building, where the loads are reduced through envelope measures and also the heat recovery VRF systems, which are using a lot less energy even under peak conditions, which is when these events are happening. Talked about that. And you'll see this more, so I thought I would go ahead and call it out. Like, our 410A has been the refrigerant, the dominant refrigerant for several decades. CO2 is our 744. You probably hear it as CO2. The reason that it's so attractive from a climate impact perspective is that the global warming potential is 1. So carbon dioxide is the basis for that whole rating system. Because we're running short on time, I'm going to go ahead and move on to these highlights of regulatory changes. So we have already been in a transition period that really started for residential systems with the transition to the leveling up of minimum efficiency ratings, so all systems had to, the lowest performing system sort of fell off or had to be improved in order to meet federal minimum standards. Energy Star came out with a new version, as well as CEE, which is an organization that some of you might be familiar with. They create their own efficiency rating program and tiers, which have been referenced in the Inflation Reduction Act. And so all of these things that happened actually last year. In preparation for the refrigerant transition, the UL standard 60335-2-40, which regulates primarily safety features of HVAC systems. That standard incorporated A2L, which are our new class of refrigerants, lower GWP refrigerants, into that UL 60335, as well as all of it, the other codes. It filtered down into the other codes, so Uniform Mechanical Code, International Residential Code, International Mechanical Code, and California's Mechanical Code, for those of you who are practicing in California as well. So the first change that is occurring is January 1, 2025. You may have already noticed that some HVAC manufacturers are offering systems with R32 refrigerant or R454B, which is the refrigerant that most of Mitsubishi Electric systems will be, for the reason that it has an even lower GWP than R32. So as of January 1, 2025, no manufacturers will be allowed to import single phase systems that are size 65,000 BTUH or less into the US. There is a sell-through allowance, so systems that are already in the US at distribution or in manufacturers' warehouses, that equipment can be sold through the end of 2025. But as of January 1, 2026, will no longer be allowed to be installed except for maintenance and repair. January 1, 2026 is when we'll have the same transition for three-phase equipment. And so systems that are three-phase, and that generally corresponds directly to greater than 65,000 BTUH systems. Again, we'll no longer be able to import those systems into the US. And while the EPA has not issued an official statement, we are anticipating that there will be the similar year sell-through period. So in summary, we've had the honor to be able to work on these really amazing projects. We hope that you have owners and opportunities to, who are supporting the same kind of opportunity, and hope that these examples have given you some hope and points of reference for how to make the electrification transition that we're in like a reality. We're already doing it. You're probably already doing it too. I'm not saying it's easy, but it's definitely possible. So with that, I would like to thank you, not too far over, and to open this up for those of you who are still with us to Q&A. Katie, maybe I can hand this back to you. Would you like to take control?
Oh, let's leave these slides up so that people can keep your contact information if they have questions about your projects. Okay. And thank you both for this presentation. I always love seeing actual applications of this stuff. That's what I find most valuable, to see that it can be done. We don't have any questions in the chat right now, so I'm just going to ask a couple of my own questions while people think of theirs. As the Lighting Design Lab kind of transitions more to support kind of workforce development, I was super interested to hear the credit union itself incentivized the contractor to learn how to do stuff. Mm-hmm. Do you know if they received a grant themselves to do that, or if they just thought of it.
It's
That's
it is
incredible.
it's the understanding of the ownership where they acknowledge that we're in this transition, that if they want the best work from people, they need to incentivize it and inspire. And these teams were, they walked the talk. These teams were at the table, very early on. Even, as soon as the GC got hired on, and they were hired on early, started pulling in um, tradespeople and skilled practitioners into the conversation.
Yeah, that I've not heard of that um, ever before. So I thought that was absolutely incredible.
But the idea of
And
a
then,
grant is a good one, right? Because the IRA has earmarked, funds for workforce engagement and support and education. And
yep,
I think that this would be a great use of taxpayer dollars.
yep. And Washington's already applied for it, so we've got funds coming. We'll know
Yeah.
more about what programs they're going to go to or what grants the state will be offering in the coming months. It's going to take a little while for them to do that, but um, Sarah wanted to know um, what your thoughts are, what Kimberly's thoughts are, but Karen, you can also chime in um, o- on the CO2 heat pumps. What are your thoughts on their maybe performance, the cost?
Mhm. So there are, at this point, for these systems, it's a more narrow application where this is appropriate. So it really is like hospitality and multifamily applications where this makes sense, and where you can start seeing um, the numbers makes sense. It's also really good in cold climates, again, because it has the refrigerant itself has the chemical um, properties to be really good at providing those huge temperature lifts in single passes. So what I'll say, and hopefully I'm getting to Sarah's question, um, it's not the right product for broad applications, but um, if you have a multifamily project or a hospitality project where, again, this we were only seeing a piece of the total system, so you also require storage tanks. We're currently delivering some of these on skids, so that like the whole system is basically, and all of the components are delivered as one um, from us. There's a demonstration project in Seattle. Karen, I don't know if you know where that is. That if folks are interested in, might be available like for some sort of group or organized tour.
Is that multifamily that was done with Ecotope?
Yes, it
No.
is.
Oh, it was done with Ecotope?
Mm-hmm.
Okay.
As
Yeah,
the as the design and field commissioning support.
yep. We had Evan Green from Ecotope gave a just sort of an overview of heat pump hot water heaters in commercial settings, and talked about that and gave a couple slides about the storage and how they um, set that up. And we had um, several members from different parts of the team that put that together. Um, give a webinar December last year, I think. So those are available um, on our website too. If you want to go back and watch, take a long lunch and watch those. Oh, and we have another question. Dilip asks, any cost information on central heat pump water heater? That's a good question.
I don't have good information on that specific to a project. We can probably pull some approximate dollars, but I don't have any good information on that.
And
I don't.
Philip, I can't, yeah, the the Bayview Tower, I know they talked about costs. I can't remember if they parsed out what each technology, each measure was. It might be worth taking a look at. Yes, and my coworker Robert said it's going to vary by capacity and what your solution is, what types of oh, now I'm going to forget what Evan taught me. What in series tanks or recirculation or how you do
Your buffer
just how
and
you do
swing
your
tank.
system.
Yeah.
Yeah,
Yeah.
yeah,
It certainly will depend on the amount of storage that you're requiring, and the climate that you're working through.
yep, yep. All right.
Since somebody asked a question about cost, I meant this is something I forgot. The ROI in that credit human building, as calculated again by the ownership, and these are financial folks, so um, keep that in mind. It was about 12 years. Their threshold was 20, as to whether or not um, they would actually, foot the upfront cost. For a 20-year ROI, but they actually came in under 13.
Oh my gosh, based on the entire project cost?
Yes.
Wow. Okay, all you smart people in the audience get to calculating.
And that's taking in that water, things like those water calculations and like really doing
Right.
the actual comparison of like, here's the building that we would, it's just code compliant, and here's the building with all of its reduced loads and smaller systems and energy and water savings.
Well, no more questions are coming in.
Thank you.
So we can go ahead and you got your presentation in on time, and we have a little time to give back to the people. Um,
Great.
thank you both. That was great. And for everybody that's still on, reminder this is recorded. It'll be up within about a week. And we thank you all for your time, and we'll see you next week, a couple weeks.
Thanks, everyone.
Oh, next
Thank
week.
you.
Thank
Bye
you.
bye.
Bye-bye.
Bye, Karen. Bye, Katie.
Bye.